Now we will try to derive the expression for electrical conductivity in semiconductors. Now, as I already said at the beginning, the electrical conductivity in the case of a semiconductor is due to the conductivity of electrons as well as the conductivity of the holes. Because in the case of semiconductor, both electrons as well as the holes are charged particles, hence the net current is always equal to the sum of the two currents. Now let us try to find out what is the current due to the electrons, and then I'll try to relate the relation for holes, then I'll add them together. To understand it, let me try to take a semiconductor. A semiconductor has a certain length L, and it has a cross-sectional area A, which is connected to a battery of certain potential. Now, according to the definition of the current is nothing but it is a total charge that is going to flow per unit time. This is the definition of the current. But we must find out what is the charge. What is the charge that is going to be present in the given conductor. Now, to understand that, if you consider Ne is the number of electrons per unit volume, Ne is the number of electrons per unit volume, and if you multiply by the electronic charge, that will give you the total number of electrons per unit volume. But this conductor has a volume V, which I can write A into L. Therefore, this much volume, these many number of electron per unit volume having a charges, so the total charges are going to be present is equal to Ne into E into A into L. That is the equation. Therefore, I can easily try to find out what is the current. Current is equal to Ne into E into A into L divided by T. But here L by T is the length in which the electrons are traveling from one corner to the other corner, and the time, which is nothing but the velocity, that is the drift velocity we have already dealt with. Therefore, I can write the current is equal to Ne into E into A into V. I can write the small V, that is the velocity of the electrons, which is also can be considered as the drift velocity of the electrons. Now come to the definition of the current density. This is called as a current density. And by definition of the current density is nothing but it is a current per unit area. Therefore, Ne into E into A into V divided by the area, where A get cancelled. Therefore, I can write it is equal to Ne into E into V. This is the equation for the current density. But according to the Ohm's law, we already learned that current density is also equal to the conductivity into the electric field, where sigma E is the conductivity due to the electrons. Therefore, G is equal to this, so I can equate these two equations. Therefore, I can write sigma E into E is equal to Ne into E into V. Therefore, what is sigma E? That is the conductivity of the electrons, which is equal to Ne into E into V divided by E, where V is the velocity, that is a drift velocity, and E is the electric field. And according to the definition, we know that a term what is called as the mobility. The definition of the mobility is always equal to the drift velocity per unit electric field. Therefore, I can write the conductivity to the electron is equal to Ne into E into V by E, which is nothing but the mobility. Now, this mobility is due to the electrons. Therefore, the conductivity due to the electrons is given by this relation, that is equal to Ne E into mu E. But as I already said, the conductivity is not only due to the electrons but also due to the holes. Therefore, if you consider in a similar manner in the given conductor, let NH the number of holes that are present, and they are all having the mobility equal to mu H, and the charge of the holes is also equal to the charge of the electron. Therefore, I can say the conductivity due to the holes is given by the relation sigma H, which is equal to NH into E into mu H. Therefore, the net conductivity is always equal to the conductivity due to the electrons and the conductivity due to the holes. Therefore, I can write it is equal to Ne into E into mu E plus NH into E into mu H. where I can try to take the electronic charge outside. Therefore, Ne into mu E plus Nh into mu H. This is what exactly the equation for the conductivity in the case of a semiconductor. However, Ne and Nh in the case of a pure semiconductor, they are equal. They are always equal. Therefore, in the case of a pure semiconductor, we are aware is that Ne is equal to Nh. So in general, I'll write Ni. Ni is the thing but intrinsic charge carriers. Therefore, I can write the value of sigma is equal to E into Ni altogether into mu E plus mu H. So this is what exactly the expression for the electrical conductivity in the case of a semiconductor. Therefore, as I already said that the conductivity in the case of a semiconductor depends on the intrinsic charge carriers, that depends on the doping, and the mobility of the electrons as well as the holes that are present in the given materials. This is the conductivity.